Welcome. If I have 2 oranges in this hand and 3 oranges in this hand, how many oranges do I have? Hello, my name is Paul and this is Barebones Tech. The ability to take 2 numbers and combine them together into a single overall value is one of the most basic of arithmetic operations. We call it addition. And in this video, we're going to look at how it works and what we are actually doing when we add 2 numbers together. In order to visualize what's going on, let us consider a line with numbers marked along its length. In a flash of originality, we call it a number line. Now, since numbers go on forever, we can say that the number line extends forever. So we indicate this visually by putting an arrowhead on it as a way of saying, and so on. For the time being, we are focusing on just those numbers below 10. Okay, so taking our oranges question from the introduction, we can see that we start with 2 oranges in one hand, which we can mark on our number line here. But we have 3 more oranges in the other hand, so we can count forward 3 spaces. 1, 2, 3. And we see that we end up here on the number line, 5. We have 5 oranges altogether. We say that we have a total of 5 oranges, or that the sum of 2 and 3 is 5. Of course, that's a lot of words, so we use shorthand. We use the cross or plus symbol to represent addition. So we could write this down as 2 plus 3. Whenever we have 2 things that are the same or equal, we use the equality symbol or equal sign, which is 2 short horizontal lines. 2 plus 3 equals 5. Now this approach, known as counting on, works, but as budding mathematicians, we always look for a more efficient way to do these things. Let's take some slightly bigger numbers and see how we could do this using our number line. According to the recent census, there are 138,053,563 males and 143,368,343 females in the United States. So, using our newfound skill of counting on, we extend the number line out, find the first number here, and next we count on. 1, 2, 3, 4, 5, 6. No, that just isn't practical. We need an improved method. We need an algorithm. Remember them? So we begin with what is known as the number bonds up to 10. Why 10? Because we're working in decimal or base 10. If you don't remember what that means, go back and watch my previous video. So, what are number bonds? Well, put simply, we work out all of the possible pairs of single-digit numbers and what they add up to. Elementary school teachers consider learning these as a milestone. So the number bonds up to 10 gives us That's a lot, but we have a trick up our sleeves. Let's look at our original problem again on the number line. We started at 2 and counted forward in 3 steps to reach 5. We could, however, just as easily have started at 3 and counted forward 2 spaces and ended up at 5. In other words, 2 plus 3 equals 3 plus 2 equals 5. It doesn't matter which way round we do the addition, we get the same answer. Of course, we have to give this new concept a name. We call it the commutative property. Okay, so how does that help? Well, if we look at our number bonds again, we see that with 10 exceptions, every single item appears twice. So we don't need to worry about them independently, and we've more or less halved the size of it. Right, so back to our algorithm. Let's begin with a slightly easier problem. 12 plus 34. Step 1. We write the 2 numbers one above the other with the digits lined up and the units, right-hand column, one above the other. The standard format is to indicate the operation, addition, by writing the plus sign here, and then put a line underneath so we can separate the result from the question. Some people put 2 lines, and I have heard it claimed that these represent the equal sign. So now we are ready to perform the process. We start at the right-hand end and use our number bonds, 1 digit at a time, to calculate the column totals. In the first column, we have 2 plus 4, which our number bonds table tells us is 6. So we write 6 here. We then move one place to the left and repeat. 1 plus 3 equals 4. We continue until we run out of digits. 46. Now there are two more things to consider. What happens if the two numbers are of different lengths? What about 123 plus 45? Following our algorithm, we write down the two numbers and oh dear. Well, this isn't an issue. Remember from the last video, numbers have an infinite number of zeros that are not written. So we simply recognize that the second number has a hidden, unwritten 0 here and proceed as before. 168. Secondly, notice these parts of the number bond table. We can see that the totals are 2 digits. Now what? Let's consider 987 plus 247. Step 1, write the problem as before. Step 2, start at the right-hand end and use our number bonds. 7 plus 7 is 14. So we write the 4 as the answer and then make a note of the 1 here or here. Both options are acceptable and taught to kids, whichever works best for you. We call this a carry. We often say something like 7 plus 7 is 4 carry 1. Now, as we process each digit, we check if there is a carry and incorporate it into the process. So 8 plus 4 is 12, add the carry gives 13 or 3 carry 1. 9 plus 2 is 11, plus the carry is 12 or 2 carry 1. Finally, we need our hidden zeros to get 0 plus 0 is 0, plus the carry is 1. 1,234. Neat. Let's try again for our US population. Write the numbers down. Start at the right. 3 plus 3 is 6. 6 plus 4 is 0, carry 1. 5 plus 3 is 8, plus the carry is 9. 3 plus 8 is 1, carry 1. 5 plus 6 is 11, plus the carry is 2, carry 1. 0 plus 3 is 3, plus the carry is 4. 8 plus 3 is 1, carry 1. 3 plus 4 is 7, plus the carry is 8. And finally, 1 plus 1 is 2. 281,421,906. Is that it? Basically, yes. There are a few additional details and observations. Notice how in our number bonds table we can at most carry 1. Notice also that when we do have a carry, the largest units we can have is 8, or 1 less than the largest digit. This means that even if we add in a carry to our single digit addition, we can never carry more than 1. We cannot get to a point where the digit total is 20 or more. Now, we did all this in decimal, but the process is exactly the same in any other number base, including binary. For binary, however, our number bonds are much easier as we only need the number bonds up to 2. So let's apply our algorithm to 5 plus 7 in binary. We know the answer we should get is 12, so let's check. 5 in binary is 101. 7 in binary is 111. Okay, so first we write in the numbers one under the other, aligning the units. Starting from the right, we have 1 plus 1 is 0, carry 1. 1 plus 0 is 1, add the carry is 0, carry 1. 1 plus 1 is 10, plus the carry is 1, carry 1. So the total is 1100. If we look at our binary decimal chart from last time, we can see that this is 12. Again, notice that we can never carry more than 1, and again, when we do carry, the maximum units digit is 1 less than the maximum, or 0. So even with a carry, we cannot carry more than 1. Awesome. This also illustrates an important concept in mathematics. If we can perform the same calculation in 2 different valid ways, we should get the same answer. We can use this fact to both verify our work and to verify that any other method we may come up with is valid. I will leave it to you to try verifying that a calculation such as 17 plus 5 gives 22, regardless of whether you use the number line and count on or use the algorithm. Finally, we need to address one other property of addition, the associative property. Another long word. What this means is, if you have 3 or more numbers to add together, it doesn't matter which pairs you add first, you will always get the same answer. So, say I had 3 oranges, 4 oranges, and 5 oranges. I could add 3 to 4 to give 7, then add 5 to 7, which as we've just seen is 12. But I could also add 4 to 5 to get 9, and then add 9 to 3 to get 12. I could also, using the commutative property mentioned before, swap the 4 and the 5 and say 3 plus 5 is 8, then 8 plus 4 is, once again, 12. This may not seem like a big deal, but down the line we will see that this can matter, both causing arguments and resolving them. In the next video, I'll be looking at what many people would say is the opposite of addition, subtraction. You don't want to miss that, you know the drill. Please subscribe and ring the bell. While you're at it, likes are appreciated and comments welcome. Finally, share this video with other like-minded folk who you think would enjoy it. Once again, my name's Paul and this has been Barebones Tech. Until next time, thank you for watching.